So there's two very old projects that have been worked on for years that are really good for programming. Unfortunately, they both are also time sinks for you to learn how to use them, but they're worth it. One is Vim, and basically, the advantage of Vim is that it's pretty much installed on every computer, including if you've got a Mac, it's already installed on there. It's pretty much installed on any Unix computer just by default, or Vim is VI improved, so it's got a lot of advanced, powerful features. And Emac as well also has a bunch of extremely powerful features. And Emacs also has the advantage of you can actually edit the code of the editor and add its own functions. Both of them are extremely powerful. And they take about an hour to get, to get going when in fully, and then from there it's just a matter of just muscling your way through everything else. But they're very powerful, and I know for a fact that people live inside of Emacs, and that's essentially the only program they have to use. VI, you can do all your editing in there. Let's see. So Andrew, classroom. Let's go with more functions. Okay, so we learned about functions, right? That essentially we define a function as like a subprogram using the word def. Okay, and we can basically do let's use the one over here on the right. Hello, and it can take in a parameter. The parameter, you don't have to define the type, and then it just executes whatever you tell it to do. So if I put in hello, hello space plus name, right? This program, once I call it with a parameter, it will essentially it'll run with this parameter. Whoops. There we go. And it says, hello, Andrew. Right? Not too exciting there. Right? I passed in a parameter, and that parameter, so it will work so long as I pass it in anything that makes sense. Hello, 1, oh, it needs to be converted to a string, right? So passing in 1 won't work, but if I put in string here, which says take the parameter name and convert it to a string, now it will say hello 1. Okay, that's interesting. Yes?
So what happens if you put like quotation marks around 1?
Well, now I'll be turning a string into a string, so it's going to work.
Okay.
So it's definitely going to work now. The other big thing we can do over here is return stuff. Right? We could do that with a classical function, f of like x, right? So we've got a classical, just kind of classic function here, return 2 times x. Okay? And then what I can do is I can call f of x. Now the big thing here to remember is like if I call f of 5 or f of 4, it's not going to do anything because I didn't tell it to print out anything. Return is not the same as print. Return means you get information back outside of a function, right? So here I got to say like y is equal to f of 4, and then print y. Make sense? Now in let's see. So a lot of the exercises I had you working on said, or some of the exercises said to return like true or false, right? So for let's see. So I think in this, like for here, if we go to our assignments, right, with the second set of loop problems that I gave you, it was to return the number of vowels, right? Oh, sorry, the first one. Yeah, the first one in the second set of problems. Did I say the second one? Okay, so return the number of vowels. Function which, given a string, returns the number of vowels that were in the string, right? Right. This is a common kind of problem, and once we get into further into today, where I'm talking about loops and stuff, lists and stuff, it will get even better. So let's see. The other big thing I want to point out is the none value, which is that there's a special word that we use in Python that indicates nothing. It's called none. Notice that I just said none and it printed it out like it was a string, like no problem. This means that there's nothing there. And we can, print over here is a function, right? Print y is a function. What if I get a return value saying like, yep, I'll go ahead and use what they do. Spam print y, and then I print spam. Okay, print y is equal to, so print y will take what's get returned by print and put it into spam, and then we'll print spam, and it prints out none. Let's actually look at hello and put y into hello, right? So hello 8, so is equal to spam, print spam. And notice that when we print out spam, we get none. Now, whenever you have a function that doesn't return anything, well, functions kind of return stuff. They always have to, and it will just simply, if you don't return anything, it's going to return none, the word which indicates nothingness. Okay, means that nothing is there. So as they show here, none equals spam. It allows it to become that's a true statement. So that's just an implicit argument there. Another thing that we mentioned is that if we have a variable over here, and actually I call it z over here, that we can't access it outside of this block of code. Print z, right? Print z is not defined because z exists inside of here. On the other hand, if I say y is equal to 12, and I go into the f of x function and say print y, let's see, let's just go ahead, right? It just went ahead and printed, well, let's see, did it print it? F of x, print y is equal to 12, print, let's go and switch this to done. It did not print y. Interesting. Does y not exist at this moment? What if I put y? Maybe if I put it before the function. Nope. So here's the relevant thing. So there's local scope and then there's global scope. Okay? So variables exist inside here are local variables. Variables that are on the outside are global variables. So code that is global cannot use anything that's inside the local. But if you're local, you can access the global stuff. So let's go ahead and say over here we do z is equal to 2x plus y. And y in this case is global. Oh, okay. Oh, that makes sense. We weren't calling f of x. That's why we weren't printing it out. Simple question with a simple solution, right? So let's go ahead and do f of, I was wondering what was happening there. so let's go ahead and do f of 2. Z is equal to f of 2. So 12 span is equal to hello y. So why are we getting, how many print statements do we have? We have 1, 2, 3. There we go. That makes sense. 12, hello, 12, done. So you can access, so if you're in a local variable, you can access the global variables, okay? But if you're in a global thing, you can't access a local variable because that exists locally for that function. Okay, and that once you use it, it kind of makes sense, right? And it allows you to reuse variable names, right? So I actually can just call things, x, y, x in one function and x in another function. So that's kind of the big thing I wanted to just make sure to go over. Now, that allows us to get into the really interesting stuff, which is lists. Okay, so we've been dealing with like single bits of data, and now normally in Python, in Java, this is a bit of a pain, especially like before an exam. And this part will not be on the exam, although it could be useful. But it's useful to know, like, so list example.py. Yes.
So you know the PyCharm stuff,
Mm-hmm.
and all of the things, all of the products from JetBrains.
Mm-hmm.
Students get free licenses.
Right, you do. I use the free version anyway. So, mainly because I'm not sure. I don't want to get into any licensing issues with me putting it on YouTube or anything like that. So, and if I decide to monetize anything, I don't want to get into any weird issues there. So, so lists are really fantastic, and they're exactly what they sound like. They're lists of stuff. So let's go ahead and just use the interpreter for a bit. To declare a list, such as L, I just will simply say L is equal to, let's say it's a list of numbers. 0, let's call it 1, 2, 3, 4, 5, 6. So a list is just a bunch of stuff that's separated by commas and put between brackets. Now what makes it really useful is that to access lists, they have the same notation you would want to use as you would want to use in strings. So let's go ahead and create a list of strings. Very common things. A very common thing to have a list of strings. Hello, world, in a list. All right. So we've got five strings in a list. Everybody see that? So if I print out this, so let's go ahead and say if I print out this list, and let me actually do this so that it's easy to read. Print list. So if I print out L, it prints it out all the strings separated. It doesn't print it out all at once. Now the other thing is that we access each individual element like we would an individual character in a string. So if I were to ask what is L2, right? This is going to get element at index 2 in the list, right? Now if you remember, character at index 2 was the third character in a string, right? So if we were looking at hello, it would have been L. I'm saying if we were looking at the second character in hello, but yes, hello is at index 0, world is at index 1, int is at 2, 3 is at A is at 3, and list is at 4. So actually, technically, strings are list-like structures. Lists aren't like strings. Strings are actually like lists. So L2 is in, and we can in fact use the slice notation. 0 to 2. So this will get the first two items in the list, hello and world. Okay.
So it's non-inclusive as well.
Yeah, it's everything's non-inclusive is inclusive exclusive. So it's the same exact notation. Or if I want to get every other one, 0, right, 0 to the last one, which is 0, 1, 2, 3, 4, so up to 5, and every other one is by 2. Although, if remember, first one and last one are implicit, so you can do a nifty trick like this. And this is really cool. So if you leave out the first element, it assumes that you want to get the very first element. If you leave out what you want to go up to, it assumes you want to get the last thing in there, right? So I want to get the first thing through the last thing, and I want to go every other one. It works for strings as well. So if I were to do word is equal to L0, right? Word, first thing, last thing, by 2, every other one, gives me HLO. Nice like that, right? So lists, you can put anything in them, unlike in Java where basically with arrays and other programming languages with arrays, you can mix and match your types. 1, so now list is a very weird list. It has a number, a string, a float, and another list inside of it. Now, before this starts freaking you out with lists of lists, I mean, you make lists of all the time. Like, you might have consider lists like, a shopping list. You might have a shopping list for one store and a shopping list for another store if you have to do, a trip to 2 different grocery stores, right? Right? You have your first list and you have your second list. Okay? In fact, one of my favorite Wikipedia pages is list of lists. Is a Wikipedia page up here that says is essentially a list of, so let's see, literature, list of books. And then it has lists of books about anarchism, or lists of books about bagpipes, there we go. And then it's a list of books about bagpipes. So it's a list that leads you to a list of lists. So it's a list of lists, which is actually kind of interesting. So it's just nested like that. Now, typically we don't like to go any further than lists of lists, right? Mainly because when we have a list of lists, that's 2-dimensional, as we'll see in a bit. As opposed to lists of lists are 3-dimensional and therefore way harder to visualize. But here, as you can see, we can have a list that's 1, 2, 3, right? We can have cat, bat, rat, elephant. So a list of strings. We can have a list of all different types. They have a string, a float, a boolean, a nothing, and an integer. And you can access and you can store it in a variable. So let's say we store that list in spam. So we've got cat, bat, rat, and elephant. You can access cat by asking for index 0. Index 1 will get you bat. Index 2 will get you spam. Index 3 will get you elephant. Right, so let's go ahead and copy that. Spam is equal to cat, bat, rat, elephant. Spam 0 is equal to cat, spam 1, bat, spam 3 is elephant. And just like in a string, if I say ask for spam 4, which is the 5th slot, which doesn't exist, I get an index out of bounds exception. right? I say you went way too far. And just like in a list, in a string, I can go negative. -1 will give me the last element. -2 will give me the second to last element, right? So everybody keeping up with this so far? It's not any different than strings. Okay. So here's also you can use this notation on a literal. 1, 2, 2, 3, right? Here I've got 1, 2, 3. And then I can do the first, and I can ask for what's in index 1 there. And it'll give me 2. Don't do this. This is confusing. Like, it's like less confusing when you do it with a string. But still confusing, right? To have this, it's almost always more readable if you store it into a variable. Let's see. So so again, you get index out of bounds errors if you try to go out of bounds. And oh yeah, something I haven't pointed out but is pretty obvious. Spam 0.5 won't exactly work. There are no half indices, right? All right. So the other thing that gets a bit crazy is so now I can but since you can mess with lists like this gives us insight on how you can mess with two-dimensional lists. So if we go back to, and I'm not exactly going to go there. I'm going to step into there just, right, we've got spam still. We've got cat, bat, rat, and elephant. So what if I want to get the second letter of print out the third letter of each of them? Right, spam. So what if I want it? So spam gives me cat. Now what if I want to get this last letter of index 0? I can add in a second indice marker. So this is where it gets a bit interesting. Right? So remember, this is an expression. It resolved into cat, which is a string. Then I ask for the second thing in cat, which is a t. And obviously can't really go any further than that because there's nothing further to go into, right? There's nothing further to go into. There is no, it returned a single string, right? Can't go any further into that. Right? So let's go ahead and look at this. So here, with their example, they've got spam is equal to cat, it has two lists in it, cat and bat, and 10, 20, 30, 40, 50. So to get the first list inside the list, I can ask for spam 0, which gives me the first list. To get the second list, I go spam 1. Okay. Now, what if I want to get the first element inside the first element? First element inside the first list. Well, in that case, I would go spam 0, and then the first element in there is in 0, so I get cat. What about the first element of the second list? So this says go into the first list, right? This says let's go in one layer and let's go in another layer. 10. Okay. And we've already talked about negative indexes. We've talked about the fact that we can do this with slices. It's perfectly fine. The last thing I should mention is that if I want to know how big a list is, I can ask for the length of the list, this might be the only thing slightly unintuitive, but it makes sense. So spam, which has two lists in it, its length is 2. It has 2 elements in it. Length of spam 1, so the list of 5 numbers in it, is 5, right? So the length is how many items are in the list. All right? The other thing we can do with the list is that to remember, we didn't really think about this much, and I didn't really talk. Yeah. So another thing we can do with lists, by the way, is something we really haven't had a need to do it with strings, which is we can change variables. Sorry, we can change elements in a string. So let's go ahead and say, let's see. Let's see. I'm just trying to think of a word. So let's say I've got a word and it's equal to bodcat, right? Not actually a cat, a bodcat. It does sound like it would be a really strong cat though, a bodcat, right? If I want to change it to bobcat, I can say word. What I can do is I can go word 2, right? Well, that's the one that's misspelled, right? The D in there is misspelled. So 0, 1, 2. I can say index 2 is equal to B, the letter B. Oh, strings don't support assignment, so you can't do it with strings. Well, that's okay. Lists, though, you can do that with. So this is pretty close. So I'm going to teach a bunch. So I'm going to teach a couple of things together. So strings are kind of like lists, though, and I can turn things into a string. Can I turn something like a string into a list? And the answer is, of course you can. Word is equal to list word. Now let's see what word is. It gives me, if you can't see, it turned it into a list of a whole bunch of single letters. So list this is actually kind of useful. You can take anything and it will spit out a list. If I give you it, let's see what we can do with it. If I give it 3, it'll just can't give you an integer back because it's not something you can do really. But anything that you can turn into a list, there are a lot of interesting things you can turn into a list, and I showed some people that last Thursday. Like you can throw a range in there and it will turn your range into a list. So, but let's go back to, yes?
You can be like variable equals list, parentheses, and then word, or word.
Yeah, and I did that, and notice I changed word into a list of words. So I did that there. Good question, though. So now, though, I can say 2 is equal to 2 is equal to, what is it? B. And now I've got BOBCAT. So lists, you can switch the individual elements in them. Strings, you can't really change them because they're immutable. You can't really change strings, but you can change lists. Yes?
Can you insert so that way you don't get rid of the D and it like shifts it down?
An excellent question. I'm going to get into that. That will be the next part. So it's going to be after the next part where we talk about list functions. But yes, you can actually do stuff with lists like this. But here we did a replacement. And now to pack it back into a string, any suggestions as to what to do? Yep.
Word?
Yep, string. Word is equal to string word, which, by the way, actually gives me the homework assignment. Turn the list into a string. Did it work in Python too? Possibly. We do probably need a for loop. Put everything in there with that. So, let's see. So let's go ahead and look at for loops. So for loops. So we'll go ahead and look at that because I've actually got finally have an idea for your next assignment, for what assignment I want to hand out with this, or at least exercise I want to hand out with this. So let's look at for loops. So for loops, we've been dealing with these standard for loops. For I in range. In fact, I'm going to go over one of your So I'm actually going to go over one of your homeworks that you were doing because I went over this for people who had solved it, but I want to show everybody, right? So So the number of vowels. So let's go ahead and look at number of vowels. Okay. So I'm going to do this one from your homework. So no excuse for not turning this one in now. But I'm going to assume that everybody's done it at this point. So num vowels. Okay. Now this one we're going to be taking in a string. So I'm going to call it some text. Okay. And the idea was we are going to count the number of vowels in the string. So count is equal to 0, and then at the end of this we're going to return our count, right? We're going to count the number of number of vowels, and if I see a vowel, right, I can do that. Now, what I'll do over here is just simply so I can not have to mess with the, let's see. So your solution probably looked something like this. For, let's see. So there were a couple things. I think for letter, right? I showed you how to do this. For letter in text, right? So for our letter in text, if letter equals A or letter equals B, sorry, well, not B, E, right? It probably looks something like this, right? And then copy paste that U, O. So if the letter was A, E, I, O, or U, right? Count plus equals 1, right? We incremented count by 1, okay? And it turns out basically that we can do something similar with the lists, right? So say we have over here, say I wanted to write a function called count evens, okay? Which says, you know, returns number of even numbers in a list. This is a common exam 2 question I like to hand out. So, or something the equivalent, or something that's like that. I think last year I used like number, it was not evens, but number of things divisible by 10, right? So num evens. And what it takes in is a list of numbers. So I'll just call this numbers. All right. Now numbers is a list, right? It will look like something like this, right? So if I pass in 2, 4, 5, 6, then the answer I'm going to get back is 4, right? So this is the input, right? Now, the nice thing is that we can tackle this exactly like the number of vowels problem. So if count is equal to 0, and then we can say for number in numbers. I like doing it like this, like for the thing in the plural of things, right? So for the singular in the plural, right? For each number in numbers. If the number is even, so how do I check if it's even?
Modulo 2.
Yep, modulo 2. If number mod 2 equals 0, count plus equals 1. Return count. Okay, so if I do num, so if I print num evens, and let's say 1, 2, 3, 4, 5, 6, this should return 3, and I'll print out 3. So that returns 3, right? So I printed out the function call right there. Okay. So so interestingly enough, over here in number of vowels, though, this actually is a great place to talk about the power of the in statement. Okay. Because there is, as I showed a lot of people, there is a shorter way to do this. A, E, I, O, or U, right? That's kind of an annoying thing to have to handle, right? So what we can do is that we can talk about what vowels are. Vowels are equal to Well, let's list all the vowels. A, comma, E, comma, O, I, and U. Now, this works very well with the string, just as well as the string, but since we're talking about lists, might as well keep it with lists. And the nice thing about Python is that it works exactly like you expect. If letters in val plus equals 1. So you can use the in statement, not just like for iteration, but to check for membership. So let's take a look at that. Let's pass in a string. So print num vowels A, B, C, D, E, F. There's 2 vowels in there. Oh, name num vowels not defined. Oh, that's just because I call it num vowels vowel over here, so let's change it to num vowels. Names letters is not defined. If letter in vowels. There we go. So now 2. So this in says, is this individual, so it goes at the A and says, hey, is this A in this list? Oh, it is. So that's true. So I'll increment count by 1. Is B in vowels? No, it's not. Is C in here? No, it's not. Is D in here? No, it's not. Is E in here? Oh, yes, it is. Is F in here? No, it's not. So there's no need to really like iterate a second time over it. Like you don't need to do a nested for loop. Like it for vowel in vowels. If letter equals vowels, right? Count plus 1. Yes.
So would you be able to do that with like a list of 3 different words?
Yes. Like let's see, will this work for a list of 3 different words, like this thing over here? Like if I passed in 3 different words? Like a
text equal the list of cat, dog, and
cat. Let's see, cat. Well, let's see what happens. And then let's see how we can change it. Dog. And I'll use bat here because short. So 0. Because what's it doing? It's looking at cat, and it's so it considers cat as a letter here, right? But again, if we throw this thing is a string, maybe we say text is equal to string. We say text. And now we turn the entire thing into a string. Now, mind you, each of those things are separated by commas, but that kind of works. Mind you, what are we getting out of this? We're getting let's see, string. So doing that worked, but didn't exactly work like we thought it would. It just created a string that looked like this. So we need something else that will do that. Let's see. How to merge strings in list. Python. Python concat string with list. I use the string join command, but if I do this, I get hello, good morning. String.join. So one way to do this is to simply say to have word is equal to. So one way to handle this one, that whole problem, is to use string.join. So you can write a function called combine, def combine, which will take in a list of words. Output is equal to, let's see, output is equal to empty string, and then output dot join and then return output dot join words. That's technically the easiest way to do it, I think, but it's not necessarily the most intuitive way to do it. So let's do it a bit of a more intuitive way, even if it's not exactly well, yeah, well, there's common operations you want to do with strings, but concatenates all the elements of the list into a string and return it, right? And again, the easiest way to do that is to add them all together. So instead, let's go ahead and iterate through a bunch of words. So for word in words, it's not necessarily the most efficient way, but it's the most intuitive way for what we're doing. So for every word in all the words, output is equal to output. So what we currently have as the output plus the current word we're on, right? So we're concatenating what we have with the next word, and we'll return it. So let's go ahead and print what happens when we combine cat, rat, dog. Oh, well, that won't work. We need a list. We need a list there, and then we need that, and now we run it. And it combined it into one string, which is cat, rat, dog, which is useful for our previous problem that we were having with Bobcat. So we just need a for loop to combine all those things back together, or a function like combine to combine all those things together. Okay. So that leads us to one of my favorite little programs that we can kind of work on that's kind of fun for everybody. And I think this is one that I want to see how well you guys can do. So let's go ahead and get started on it, and then I'll see, and then you'll take it off from here and submit it as the quiz grade for today. Okay? So this is a fun little game in the United States that I think everybody knows about. And I have a particularly nasty version of this if you want to that I can give to the overachievers next week. This is Hangman. So how many of you do you know what Hangman is? The game? No. Okay. Because Japanese, of course, uses a completely different alphabet that would make it terrible. Can you imagine playing Hangman in Japanese? It's not. It doesn't work. It's an American game.
No, it's got less. We got less. Japanese has less. Options.
The Japanese has all the words are
If you're playing it with hiragana, then you'd get 40. Then you have 46 different hiragana.
Well, 46 plus the 10 which are mixed.
And then assuming you're not playing with kanji. Okay. So all right. So quick rundown on quick rundown for everybody on the way Hangman works. Okay. Hangman works on the premise that there is a hidden word over here, right? That I am thinking of a hidden word, and I've got this like gallows over here that I'm going to hang a guy on, okay? Because kids are morbid like that. So the idea here is that you guess a character, okay? So I'm thinking of this hidden word, okay? And you guess a character in this hidden word, right? So guess a character. You don't have to guess a specific character. You're guessing, is this in my hidden word? T? T is not in my hidden word, so I'll list it down here in the things that are already guessed.
Vowels are the first thing.
Right. Typically, and what I'll do is I'll draw the little head over here, right? And so you get so many guesses, which is however many body parts it decide to draw before the guy is fully drawn, right? And at that point, if the guy is fully drawn, then you lose the game. Right. So, however, if you guess like a vowel, what's the most common vowel? E. Right. Okay. So he doesn't. So he doesn't get another part of him drawn yet. Okay. Okay. Right. So now you guess another letter, and so O. Yep. So you keep guessing until.
Hello.
Yep. So well, in our version of the game, all we're gonna do is just guess the letters until it's all completed. So because that makes it easier, that there's less options for us to program. Right.
Are we printing out Axiar for this too?
Sorry.
Are we printing out
Don't
Axiar?
put that in this.
No. So if you guess L next, right, you reveal both the L's, okay? And so the game continues until until you run out of guesses or until it's fully exposed, right? Or unless the word is fully exposed, you can win. Now this is actually a bit of a fully fledged program, so I'm actually going to start programming it with you, and we'll work our way through it, and then I'll leave it up to you guys. And this is actually the reason I want to do this one now is because it was kind of non-trivial. It's like for when I've had to do this in Java, and I stopped giving it in the Java class. When I've given it out, I've had to tell students, here's a special function that will replace a character in a string for you, right? So that's one of the things what we're going to do. Like, let's say, so your program should probably look something like this. First off, let's figure out what we need for the program. First thing we need is a secret word, right? Right, and we're just going to hard code this in, so it's going to be the same game of Hangman every time, right? Let's say our secret word is Bobcat. Okay, mine it might be Bobcat, or you might use banana, right? Whatever, doesn't matter. And then we'll have maybe so that's my secret word, and then we have so that's hidden from the user, right? That's how we remember what we're actually working on. Then we need this thing over here that the user is going to see, right? Which is the blanks. So maybe I'll call it user view or blanks. I'll call it user view because it's what the user sees. And what they should see is one blank for basically every word. So you can use question marks here if you want, or you can use underscores, right? How do I know that I'm using the exact same? And if you change your secret word, you have to change the number of underscores. So that actually, though, makes it pretty easy to do, because what we can do is that we can just simply say, I'd like a question mark or a blank, and then thankfully in Python we can just multiply that by the length of the secret word, right? That gives you exactly as many blanks as you need. Right? So, let's see. Now, the other thing so then we also have like the number of guesses, right? And let's say they get, 7 guesses. Okay? 5 or 7, you can, how many things wrong they can guess. And then what I like to do is I like to break it apart into functions, what we call a top-down approach, essentially. So let's go ahead and essentially it just works like this. They all have a big function in here called play game. Okay? That's what we're doing. We're going to play a game, right? And then let's look at play game, right? Notice that I called play game without actually ever writing it, right? I just called it saying I'd like to play the game, because what I'm going to do is I'm going to break up play game into more functions. How do I play the game? Well, this is a game that basically we play until one of two conditions is met, right? While the number of guesses that the user has is not equal to 0, right? That's how long we want to play this game for. Like we're just thinking through the steps of the game and writing down as best we can the steps of the game, and then we're going to fill in the individual steps of the game. So while the number of guesses is not equal to 0, and so both of these things have to be true in order for it to continue. if either of these becomes true, then we want to basically immediately switch it to, we want to stop the game. And user view, right? The thing is that basically we stop when the user view is full of letters rather than blanks, right? Once this is full of blank, as soon as we don't have, when there's no longer a single blank in here, right? That's when we want to stop. That's another condition we want to stop, if there's no blanks in here. So, surprisingly, this works, by the way. Let's call it, and I'm not in. So while there's still a question mark in there, and the number of guesses in user view, and we still have, so long as we still have a blank mark in user view, and the number of guesses not equal to 0, we want to keep playing the game. Right? That makes sense to everybody? Now, I'm going to... Okay, so what does playing the game look like? Let's split it up into a couple things. First, let's get the guess from the user. Guess is equal to get guess. So I'm going to just make that as a function, right? Notice how I just, again, call the function an undefined function. So I'll put def. So I'll go ahead and just define it as a stub like this. This is like pretty much how I work with all my programs. Okay. Get guess. Is in there. So, and then what I can do is that to make sure that it compiles, even though it's not going to do anything, I'll just put it past. So this way it will compile. If guess is in secret word, I have to do one thing. Otherwise, if it's not in the secret word, so if the guess is in the secret word, I'll come back to that, right? If the guess is in the if the user guessed correctly, I'll get back to that. But if they get it wrong, what do I do? They got a number guess wrong, so I do number. So I mock the user, right, for getting it wrong. Ha ha ha, you're wrong, right? And then number of guesses minus equals 1. Okay? Right, so that seems like a good way to do that. Now, if the guess is in the secret word, that's where things are getting a bit, this is where basically all the bits that you're going to put, that's the part that you're going to have to put together. Okay. So get guess, and then let's see, if the guess is in the secret word, update, right, we'll need to update the user view. Now these two functions that I'm declaring are pretty short actually. But I think I'll leave it to you guys to do those. You guys can also take a break before you start working on this. But this is what I want to work on basically a bit for the rest of the day before we go on to doing a bit of review for the exam on Thursday, which I'm sure you would love to have some time to review stuff, right? Okay. And to update the user view, what do you have to do? Well, we have to look for anywhere that this guess occurred in the secret word and update it. Now, this involves us iterating through a word and finding the index of a number, right? So let's go ahead and just talk about how to do that. Or actually, we can just look at your textbook and ask about how to do that. So you can ask any list, and this works and I believe this works for our for your let's see. I believe this works for your for strings as well, that if you ask for the index of something, it will give it to you. So let's go ahead and look at our interpreter to show you what I mean. So this is one of the keys you'll need for this. So, right. So the useful thing here is to temporarily switch the secret word in the user view into a list. Just temporarily change them into lists so you can change them up. The secret word doesn't need to be changed into a list, but the user view should. But what we can do is we can say, hey, so my secret word was banana. So let's go with word is equal to B-A-N-A-N-A. And I chose this specifically because there's repeats, right? If the user asks for guess, I can go for index of A. And it'll return the index of the first A it sees. Okay. And so if I change that, it would, so if I switch this banana out, so sorry, changes the, so it finds the first index of the of A, but there's multiple A's in there, right?
So you have to do a loop.
So the other thing you can do is do a loop, which is that we can do for, leave X, comma Y, comma Y in enum. So this is one thing that I don't think the book goes over. Enumerate word, but it's very useful. Print X, comma Y, and I think this is the syntax. There we go. So if you throw your banana or a list into enumerate and throw two variables into this loop, you will get both the index and the letter. So you can get both the index and the letter, right? Because the for loop does that. So one way is to use the index. And because the index operator does take multiple variables, if I recall correctly, you can throw multiple, let's see, word index. So let's see, word.index. So there we go. It's popping up. If you notice, it pops up. Okay. Come on. Word.index. And it says you can start it. Sorry, you can do the substring. Let's see. Start to end. So it says optional. You can look for an index between two locations. So you knew, for instance, if you knew that the last one was at 1, right? If you knew that basically A, the first A was found at 1. So you can then do another call and say index starting from 1, index, well, obviously I don't want to start from 1 if I found it at 1, starting from 2. So the next one was at 3. So I think this is adequate I think this is about an hour's worth of work. So let's see how well you guys can do with this one. Okay.